Good afternoon. I really appreciate the opportunity to share with you what it is that I work toward, what my passion is, and that's making brain research on autism possible. We have no biological tests for autism. It is a behaviorally defined disorder. We know it's a disorder of the brain, but it's a behaviorally defined disorder in which we have very few biological treatments to offer. My research as a neuroscientist is to understand what is happening at the cellular level, at the molecular level, what role genes are playing, and how it is that the brain is deviating from that of a typical child. This information is necessary for us to understand what is causing the disorder and how we can treat it. So what I'm going to tell you about today is why brain donation. That's right, I said brain donation. Postmortem brain tissue is absolutely essential for us to find effective treatments for autism. It's really heartbreaking when you hear from a parent that their child was just diagnosed with autism. You want to just wrap your arms around them and say, I am so sorry. Autism came to my family in 1999, at which time we were told, we don't really have any medications to offer you, I'm sorry. 14 years later, there still are no medications to offer. But one day, because of brain research, we'll be able to say, you know what? There's a treatment for that. And this is why you need to care. More than 2 million people live in our country alone with autism. It's been called an epidemic, with prevalence rates rapidly rising. In 1985, 1 in every 2,500 children had autism. Now, today, 1 in 88 children. 1 in 88, I mean, that's just horrible. It's more common in boys. 1 in 54 boys have autism. So if you don't know someone who has autism now, although I'm guessing you probably do, you will. This generation of kids will have a huge global and economic impact if we don't find effective treatments. So what is autism? Much of what autism is are impairments and abilities that you and I take for granted in our daily lives. We're able to maneuver and understand our social world. We're able to greet friends, say hello, look them in the eye, shake their hand. These are natural social abilities that are difficult or even lost in people with autism. So clinically speaking, it's really based on 2 core impairments. That is a deficit in social interaction and the presence of restricted or repetitive behaviors. There's also what we call comorbid disorders. Most children have a nonverbal or verbal communication deficit. Intellectual disability is common. We also have, it's common to see sensory issues, anxiety, medical conditions like seizure disorder, gastrointestinal problems. These are all common. But what this shows you is autism is complicated. It is difficult. Yet, as scientists, we envision one day having tailored biological treatments. So how are we going to get there? Autism research has taken many paths. We have a fairly good grasp of what's happening at the behavioral level. We have our clinical definition. Remember, though, behavior is a result of what has happened in the brain or is currently happening. So we need to go deeper to understand the biological basis in order to get to those effective treatments. We've made great strides in the last 10 years with using techniques like magnetic resonance imaging, MRI. We can use it as a guide of when and where to look in the brain for clues about what might be happening at the broader level. But now we need to move to the cellular level, to the molecular level, understand what role genes are playing in order to get to that biological basis. All of the rest of this research requires brain tissue to study. So to give you an example, if you were to measure brain size on MRI, and you were to chart how the brain is growing, we compare it to typical development, and then we look at a child with autism. What we find, it turns out, is that in most kids with autism, the brain is growing too large too quickly. And even in some cases, we see that there might even be a decrease in size later on. So what it tells us is that it's the growth trajectory of the brain, it's the changes that are happening across lifespan that are different in autism. But the good thing is this does open up a lot of opportunities for treatment across one's lifespan. But what does it mean to say something is larger or smaller in the brain? What does that tell us? We need to go deeper. So this is what your brain looks like inside your head if you were to look at it from the side of your head. We can take a picture through the middle of it with MRI. You see that gray band around at the outside? Those are full of neurons, 100 billion neurons in the brain of that area that we call gray matter. Those little specks there at the end, those are neurons. There are 100 billion of those in your brain in that gray area. Those neurons all connect to each other via fiber tracts that run through the white matter. The place where they connect is called a synapse. There are 100 trillion synapses in the brain. So with brain tissue, we can look at those individual neurons. We can measure their size. We can count them. Turns out there might be different numbers in people with autism. We can see how they've matured, where they've connected to. We can look in the white matter to look at, we can measure the size of those individual little fiber tracts. We can look at the synapse to look at the neurochemistry of what was happening there. We can even go to the genetic level. I'm oftentimes asked, can't you just take a blood sample from someone with autism and see if the genes are different? Turns out that it doesn't work that way, that the genes in the blood function differently than the genes in the brain. So the take-home message is if you want to know about the brain, you have to study the brain. In fact, we've done that in brain tissue. We have looked and mapped at how some groups of genes are functioning. If you think of them at a high level of activation in green and a low level of activation in red, we see that, in fact, they are functioning differently in autism. But we wouldn't have seen this had we only looked in the blood. So hopefully I've convinced you that brain tissue is necessary for us to understand autism. The problem is that we have very little brain tissue to study. We don't have enough. In fact, we are literally at a bottleneck. We can't do this kind of research because of limitations of the tissue. Autism researcher Dan Geschwin once stood up at a conference and said, the lack of brain tissue is a crisis for autism research. And in terms of understanding the neuropathology of autism and the molecular events that occur in autism, that is actually true. To put it in perspective, in the 30 years of autism research, fewer than 150 brains have ever been studied. Think of that in terms of comparing it to Alzheimer's disease or Parkinson's disease, where thousands of brains are available. Or even in schizophrenia, where hundreds have been studied. This has led to great advances in our understanding of these disorders and our ability to find biological treatments. But in autism, we are at a crisis. It's not a money issue. It's not a personnel or lack of know-how. We simply don't have the tissue to study. But there is a solution, and I'm asking you to help spread the word about the importance of brain donation. It's my job to figure out how to get that brain tissue to the scientists, like myself, who need it. So that's why I started a program at the UC Davis Mind Institute. It's called Brain Endowment for Autism Research Sciences, or BEARS. The goal, it feels a little better, doesn't it? I know. Yeah. what we're going for. But it's the goal of the BEARS program is to share brain tissue with researchers around the world. That's the only way we're going to make progress, is if we share. And to make brain research on autism possible. Donating your brain is something many of us have never considered. You think nothing of checking that box at the DMV to say, I'm an organ donor. You can easily imagine how donating your heart or your kidney can go to save one person's life. But it's much more difficult to imagine how donating your brain could go to change, impact millions and probably billions of people's lives through science and research. You're probably asking, will my brain help? And the answer is yes, your brain will help. That's because you can't look at a brain and say, oh, that person had autism during life. You have to have a typically developing brain to compare it to. So yes, your brain will help. It's a difficult discussion to have. When I talk to people about it, the blank look they get on their face when they ask me, what do you do? I say, I do brain donation for autism research. It's a really difficult topic to discuss. I came into this thinking, oh my God, I have got to convince families that have just lost a loved one to donate their child's brain. I can't imagine anything worse. We don't want to think about it. I have 2 little girls. I don't want to think about that. Yet I can tell you, I have never once had to do that. Every time I have been told, thank you. You helped us through our grief, knowing that our child will make a difference in this world. I want to leave you with the words of a mom from our first donor. His name was Grayson. He passed away from a seizure when he was 16. He had autism. And during her time of grief, she thought, what could we do? What could we do to make a difference so that other parents and children don't have to struggle? This is what she said.
Grayson was a happy, joyful boy. Unfortunately, Grayson passed away from a seizure that he was never able to regain consciousness. Going through the process of donation, and it really brought us to a point where we knew that even though in our tragedy, Grayson lives on, and his ability to be a pioneer perhaps, with our contribution, we're making a difference.
So you can see the video in its entirety on our website, but please help us spread the word about the importance of brain donation, become a brain donor, and help us change the course of autism research. Thank you.